Welcome to an introduction to CO2 sensing in cars. My name is Neil Roberts. I'm the Global FAE for the automotive CO2 product line. Firstly, about carbon dioxide or CO2 and trying to put it into context. This is not about CO2 emissions, although that can be a secondary effect. It is about the CO2 levels in cars, understanding what they are and keeping occupants safe, alert and comfortable. The outside air comprises approximately 0.4% by volume of carbon dioxide or CO2. When humans occupy a space, they exhale at approximately 4% CO2. So reasonably rapidly the CO2 level in the space will rise, and more occupants will see a proportionately faster rise. In order to counter this, we need to dilute the inside air with outside air to maintain an acceptable level of CO2. Similarly, if the value rises too high, then our bodies cannot breathe, and we will die. We will explore the absolute values a little later in this presentation. Automotive manufacturers are now seeking to introduce carbon dioxide sensors into vehicles for a number of reasons, which we will explore here. This is a presentation for internal use only, and a customer version will follow. So no doubt you will have seen articles, primarily from or about the German automotive manufacturers, about using CO2, or as it is known, R744, as a refrigerant. Commercially, this is problematic as the system needs to be capable of running at much higher pressures, so there is a consequential premium to the system cost. Also, suppliers of refrigerant, DuPont and Honeywell, have developed what they see as a viable low global warming potential, or GWP, alternative that can be used with little modification to existing systems. However, both Daimler and VAG have done a number of tests and in the past have declined to use the developed refrigerant R1234YF or 1234ZE, as they have shared concerns for its flammability. Although Daimler have recently stated they may use these as an interim solution. All in all, the situation remains unclear, but each manufacturer has considered the issue and developed their own strategy. So, what are the drivers behind the requests for CO2 sensing? There are fundamentally two main drivers behind the request for CO2 sensors, and we can meet both with a single sensor. An EU regulation, known as the Fgas regulation, and progress in understanding how outside air affects the occupants and driver, and how that may be controlled to best effect. So firstly, we shall consider the regulation. The formal name of the regulation is number 517/2014 of the European Parliament and the Council of 16th of April 2014 on fluorinated greenhouse gases. For obvious reasons, it's more commonly known as the Fgas regulation. The regulation is designed to mitigate climate change and protect the environment by reducing emissions of fluorinated greenhouse gases, or Fgases. It aims to cut these by 2/3 of today's levels by 2030. This is the driver to reduce the use of so-called greenhouse gases. The effect of gases is measured by comparison, or global warming potential, to carbon dioxide. So R744 has a GWP of 1, and R744 is pure carbon dioxide. R134A, very common refrigerant, has a GWP of 1508, and comparatively R1234YF has a GWP of 4. This in itself would not be of concern. However, because CO2 is odourless and can have an effect on drivers, the VDA, who are the German Automotive Manufacturers Association, is mandating the use of high-limit sensors to monitor the car at all times for leakage, as high CO2 levels represent a danger through drowsiness and cognitive reduction. So looking at levels that affect people, two long-held critical values are the time-weighted average. So this is the amount that we can reasonably cope with, and that's 5,000 ppm. And the short-term exposure limit of 15,000 ppm. Now these levels are generally set by national health and safety executives or equivalents, and are often also enshrined in law. So by comparison, an outdoor level is typically about 400 ppm or 0.4%, and commercial ventilation standards look to maintaining a level of about 1000 ppm or 1%. So experiments releasing refrigerant volumes of gas into a car cabin, simulating a breach in the evaporator, for example, show that areas will reach the short-term exposure limits. So automotive manufacturers are looking for a sensor that will tell them a high value has been reached. Although what they will do with that information is as yet unclear. Some jurisdictions are also requesting that the sensor operates in park mode, so we've had to consider how to substantially reduce the operating current of our current technology. These values also carry on to our next slide as we try to maintain a comfortable level in the cabin or below 2000 ppm. The Telair engineering team have conducted some global research that agreed with automotive manufacturer research that many drivers put their vehicles into a recirculatory mode for too long. This is for any number of reasons, including lack of awareness about air quality, but it results in higher levels of carbon dioxide in cabin, which are proven to decrease driver alertness and can easily move towards drowsiness. For example, it is prevalent in hot climates to put the cabin climate control into recirculation to maximize the cooling effect. However, this can result in low air quality with consequential loss of concentration, induced drowsiness, and therefore the safety threat that implies. CO2 is a proven tracer for occupancy, so outside air can be introduced to the car to maintain an acceptable level of CO2 within the cabin and thus maintain driver alertness. This may be considered either as a primary or secondary reason for having a CO2 sensor. Be aware, however, that another proven mechanism to achieve this in jurisdictions where seatbelt wear is compulsory is to monitor the seatbelts and their pressure pads, effectively monitoring the occupancy of the vehicle and modulating the external vent proportionally to that occupancy. Now, I've no doubt that most of you will have noticed that putting an air conditioning system on in a car can substantially reduce the power available to drive it, as AC units are a considerable drain on power. And as jurisdictions move towards ascertaining the economy of vehicles, including keeping all the peripherals on, then the power consumed by the AC becomes something the manufacturers want to reduce. By employing a CO2 sensor to control the outside air induction to the vehicle, we can help reduce energy consumption, as heating or cooling outside air is usually the most significant user of energy. Recirculated air generally requires much less, as the temperature differential is much less. Operating exactly in the same way as a demand-controlled ventilation system, or DCV, the sensor monitors the cabin and introduces more or less outside air to control the air quality in the cabin. This in turn reduces the amount of energy consumed by the AC unit, which improves the economy of the vehicle and thus reduces its CO2 emissions. So it's a win all round. One of the few cars to have that at the moment is the Hyundai Genesis, which has a sensor from Nigeria to achieve this function. So looking at the potential markets and market values, where we may actually capitalise on it. Looking at global passenger car sales, they are in the order of 72 million cars per year. Currently, Western Europe, and more particularly Germany, is leading the change, and we can look at a figure of approximately 13 million vehicles. Breaking this down into the major players selling cars into Europe, we can see that the Volkswagen Group has about a quarter of the European car market. These figures are from January to September 2015 and have been extrapolated for the rest of the year. In 2014, Volkswagen produced about 9.7 million passenger cars worldwide. Second placed in Europe is the PSA Group, headquartered in Paris, France. In 2014, PSA produced over 2.5 million cars, almost 70% of which came from activities in Europe. And along with the fellow French car manufacturer Renault, PSA has a very, very strong presence in Europe. The two French automakers account for a European auto market share of about 20%. We currently have approached VAG and are working with them, Daimler and BMW. We are also working with Jaguar Land Rover and DAF Trucks through a Tier 1. However you consider it, the market potential is huge. So taking a little look at the technology, firstly, there is no set guide or accepted standard as to where to put the sensor at this time. Whether it goes in the bulkhead, central console, armrest, B-pillar or rear view mirror is still being determined by each manufacturer we are working with. If used in safety mode, a general preference appears to be the central console, as the CO2 is slightly heavier than air, and a failure event will be first detected in that area. It also appears to reasonably detect CO2 levels in the car when in use. Amphenol Tellair has developed a T6700 platform into a single board LIN-bus automotive CO2 sensor solution. Utilising the same technology that we have promoted and sold successfully for the past 25 years, Tellair Engineering has developed a solution that meets the needs of the German VDA with the VAG Group. The core technology remains ours, as does the board design, but certain elements are exclusive to VAG. But we can and are promoting the design concept to others. Key benefits to promote are the proven track record in producing low-cost CO2 sensors, the huge experience we have in the automotive space, it does after all account for a third of our business, and the multifunction capability of the sensor module. Specification meets the current needs of the VDA and will operate in park. This we have succeeded in doing by decreasing the sample rate but still maintaining reasonable accuracy in comfort mode. We are in discussion to use the sensor in passenger cars, but it is likely our first sales will come from long distance truck cabins, as truck regulations require ever higher standards and better energy usage. By comparison, truck regulations are several years behind passenger cars in Europe, but in some aspects they're quite forward thinking. So the technology platform exists and will soon be available in a generic format for the automotive sensor. The sensor theory is exactly the same as the industrial T6713 part, which is shown here, although changes to the firmware have been made, and obviously the addition of a LIN-bus transceiver. In order to progress an opportunity, the normal CPO system is used for evaluation, although a quick call to either Chris Rammel or myself will establish if it is likely to progress. Investment required is likely to include custom packaging and associated tooling design. It's also likely that we'll have to do a custom lin stack, although that's not a big cost. So the level, as with everything else we do, the level of customization determines the time. We probably need to allow 6 to 9 months. Looking at the competitors and competitive landscape, competitors for this business do come, unsurprisingly, from both automotive sensor suppliers and existing CO2 sensor suppliers, and in a lot of cases combinations of those two things. Sensera have acknowledged that they do not have the resource to pursue opportunities directly, and they are working with, they were working with VAG and Casco until Casco was acquired by Amphenol. Now Casco are working with us. They now appear to be collaborating with Hella. E+E are working with Daimler through Paragon, who are also a major German automotive provider. And as I mentioned previously, Nicera are already working and have a product with Hyundai. Looking at our offer, I would reiterate, we are the only company that has both automotive experience and CO2 experience. All the others are interdependent. So as a reminder, the primary points of contact at this time are Chris Ramwell as Global Product Manager, myself, Neil Roberts, as Global Application Engineer for this line, and your local FAE. Engineering will be done in Goleta, California, or in the US, and the product line is being set up in Tijuana, in Mexico. As to additional resources, we're currently building those resources for what essentially is a new application of this technology. Unlike building environments where lots of research has been done and the industry is reasonably aware of requirements, this level of expertise does not yet exist in the automotive industry. The application engineering is still being developed, researched and tested. What we do have is some data collected by the engineering office, the VDA specification that we were consulted upon through its development, and online some research can be found on values within a vehicle for charge release and for different levels of occupancy. And also the Daimler experiments with 1234YF as an alternative refrigerant and watching them go up in flames. So information at this time is quite rare. If you do have an opportunity, please liaise with Chris Ramwell and myself, Neil Roberts. As I mentioned earlier, I will release a customer version of this presentation soon, as this one does contain confidential information. Thanks for spending the time listening.